You've heard of degreeing a camshaft, but what does it mean and how does it affect power? Well, that's what you're going to find out on this episode of Engine Masters, plus Dulcich's personal quest to make 400 horsepower from our 440. It's low buck, it's low compression, it's straight out of a motorhome. Can he do it? Stay tuned to find out.
My 440 is back. Now this is a stock motorhome 440 and we tested it on Engine Masters. It didn't really make the power I was hoping for, but I think I might be able to improve on it by messing with the cam timing. Now what's that? Well, it has a big effect on power and I'll start with the basics. Here's the exhaust lobe, and imagine this is the intake lobe. I'm going to first talk about something different than cam timing, and that's the lobe separation angle. When the cam is made, there's a certain angle between the intake and exhaust lobes. And basically, if I wiggle my hands like that, this would be a narrow lobe separation, and this would be wide. But once the cam is ground, that spec is set. However, how the cam's installed in the engine is called the installed center line angle. A lot of people will confuse those two terms, but the installed center line angle is where the cam is parked in relation to the crankshaft. Now, why is that important? Because the crankshaft controls the piston position, and where the cam is in relationship to the crank is going to control how the valves are opening and closing in relation to the piston. Our test engine here, you might have seen on a previous episode of Engine Masters, it's a stone stock motorhome 440. As a matter of fact, the bottom end and the cylinder heads have not been touched. The factory pistons here are 156 in the hole. What it means is this pooch has 7.2 to 1 compression, and that's bad. Now, we did do a little modification program on this engine. In that particular episode, we put on an Edelbrock Performer RPM intake manifold. We ran this same Brawler carburetor, and we installed a comp thumper cam. It's a pretty hot street grind. It's got 227, 241 degrees duration at 50, and that's not bad. Now the camshaft was installed at 101 degree installed center line, and it's ground on 107 degree lobe separation. That's a heck of a lot of advance, 6 degrees, and the engine turned out to be kind of a pooch. It made 381 horsepower at a paltry 4,900 RPM, and honestly, I just wasn't all that happy with it. I'm hoping that by dialing in the cam's installed center line, I might be able to improve on that. I'd like to see this thing make 400 horsepower. I'm not sure it's going to get there no matter where we put the cam, but we're going to roll it into the dyno and find out.
Brule, I don't know if you've heard, but Dulcich has a new nickname.
Really?
The dog catcher.
Come on. What do you mean?
The 440 is a pooch.
Oh, seriously.
I took the collar off this morning so we could run.
Brule! Come on, man. Have a little respect. That's 440 cubic inches of Mopar power right
At 381 horsepower. You know, to be fair, this thing only makes 381 horsepower, but I'm the guy saying this cheap 440 motorhome engine package is actually pretty good for a drive-around muscle car. What does it make for torque? 470 something?
470, yeah.
Yes, and at low RPM. Even though it's not up to your standards as far as horsepower per cubic inch, I still think it's a good engine for the typical guy. All right, well, what we're going to do now is run the baseline on this thing and see exactly why we are criticizing this engine, which I say is not that bad, and Dulcich can't stand it. So here we go. And this, by the way, is with a 107 lobe separation angle, and it's in at 101, so it's 6 degrees advanced.
Lobe center line?
Yeah.
And here's the thing about that. I mean, I thought that would be good because it's low compression and that would favor mid-range and low-end torque.
Closing the intake valve earlier to capture more compression.
Yes, but I think maybe that might have been too much. And that's really why I wanted to do this test. See what would happen with the different setting on that camshaft.
It's already a small cam. Then you go way forward with it. It's just not going to have any engine speed.
Yeah.
Okay.
Okay.
Let's see.
Here we go.
coming in.
Might have picked up 1 or 2 horsepower.
Oh, no, I thought I saw an 85 there, but we'll see
Yeah.
what the numbers tell us.
Oh, that is not bad.
467.2 pound-feet of torque and 384 horsepower. Well, that 4,900 RPM power peak, I think, is an indicator that it's too far advanced.
Yeah.
And it also could be the heads are very
Turdly.
small,
And it has no compression.
and they're stock.
And they're stock. So when a camshaft is advanced, it tends to favor low-end performance, and when it's retarded, it tends to favor higher-end performance. So at this point, I guess we have to show everybody both sides of what happens with advance and retard, so we're actually gonna go out there on the cam that's way too far advanced.
And advance it more.
And advance it more. We're gonna put another 4 degrees in-ish, right?
Yeah.
Okay.
Well, that's gonna be good.
Yeah,
It's gonna be weird.
good. It's gonna be weird.
It's gonna be so bad it'll be good.
Hey, we should make one point though, which is if you're doing this on your own engine, you really need to check valve to piston clearance.
Right.
Because moving the camshaft around can affect that a lot. But on this particular motorhome 440, where the pistons are how far in the hole?
154 thousandths.
There is no chance that a valve's ever gonna hit a piston. So this is the perfect engine for this test. Ready?
All right, let's go to work.
Let's do it. Now these guys have exposed the timing, chain, and gear set, which can give you a better visual representation of what we're going to do as far as advancing and retarding the camshaft. Remember that when we give numbers as far as advance or retard, like when we say it's installed at 101, that is the position of the center line of the intake lobe in relation to the degrees of rotation of the crankshaft. You usually don't worry about that. You line up the dots here on the timing set, but this particular timing set has 9 different keyways in it so that you can move the cam around. Here's how that's gonna work. Imagine the crankshaft staying in position right where it is, but we're going to rotate the camshaft either forward or backwards. Obviously, because the engine rotates clockwise from the front, if we roll this clockwise, it's gonna advance the cam. If we roll it this way, it's gonna retard the cam. When you advance it, you make all of the valve events happen sooner. When you retard it, they all happen later as it relates to the piston position.
Changing the cam timing will also sometimes change the pressure in the cylinder. And the main reason is it changes when the intake valve closes. Having a lot of advance like we have now will close the intake valve earlier. And remember, you don't capture any compression until the intake valve closes. So, Steve-O, are you ready with the gauge?
Yep.
I'm gonna open the throttle so we don't have any restriction to air entering, and the answer is, ooh, not bad, 150?
More than I thought it would be. I was guessing, just guessing around 120 or 30, but no, 150 is not
Well, that
that bad.
explains
Makes
it.
a lot of torque though.
Yeah.
It's down low.
150 is not race engine territory by any means, but it's pretty good for a very, very low compression engine like this.
All right,
put
now
it
we
back
got work
together.
to do.
There you go. We advanced the camshaft 4 degrees, or at least we think so, because we didn't put a degree wheel on it, right? But the little mark on the doohickey
We
said
moved it 4 degrees further advanced than it was.
Right. We know it's advanced more.
And it was degree wheeled at 101, so that's dead nuts. So unless there's a little manufacturing error, we're talking about 97 degrees installed center line now.
Which means 10 degrees of advance off straight up, which is a lot.
That's about 1 degree away from missing it a tooth.
Yeah, it is. Yeah.
But I think it was advanced too much to begin with, so I'm not expecting this to improve the
this'll be
situation a
worse.
lot. But
Yeah.
it may make more torque. I mean, it'll be interesting to see what it does.
It should tip that
Right, we're
curve,
here.
right?
Yeah.
This way.
That's what it's supposed to do.
All right, let's find out.
What if it's going to make it a beast of a 440?
I hope
might.
so. I hope
know.
you're happy. I'm only here to make you happy.
I know, I
message.
want to be happy with my 440.
Okay, what we're gonna do now is our first pull with the camshaft advanced even more, 10 degrees total.
Wow, it sounds lazy. Man, that is such a lazy engine.
Well, here's our new power numbers: 466 pound-feet of torque, 376 horsepower, which is not radically different, but let's see what it did compared to the other timing setting. This is one of those engines that just doesn't care because it's a pooch. It's kind of a three-legged pooch, actually.
Actually, it did exactly what it was supposed to do, Freiburger.
It
Give
did.
it credit.
It tilted the curves,
Look at
that's for
that.
sure.
Actually, I don't know if it did what it was supposed to do. I think we made it do what it was supposed to do.
Oh, that's a matter of semantics.
What's your plan, Dulcich?
I don't like what it did there. I think if we back the cam up, it's going to be better. So I'm going to dash out to the dyno room and make that
retard it.
change. You guys are helping, right?
And the tension builds. We just retarded the camshaft to 107-degree installed center line. And we are once again going to do a cranking compression test to find out if it changed at all.
One, 3, 2.
132.
32.
So there you go. Theory proven out once again. Now let's go dyno test it and see what power it made. Okay, here we go with our third test. Now remember, in our very first test, we had the camshaft installed at an intake lobe center line of 101 degrees.
Right.
Then the next thing that we did is advanced it to 97 degrees, and now we retarded it to 107 degrees, which is what we would call straight up. Yeah, the same number as the lobe separation angle, which is sort of an insignificant, sort of lingo, but regardless, we started at one point, and then in test number 2, we advanced it, and in test number 3, we retarded it. And so theoretically, that means it should make a little bit more top-end power now, and the number I called was 392. How about you?
You know, I want more than 400 horsepower. That
Not
would
happening.
be pretty good.
No.
No.
No, I've seen this.
The 392.
I've met this
would
engine.
be so close.
I was off by 1.
Yeah, what's the matter with you, Freiburger?
I know.
You're just chiseling me when I think I saw 393.
Yeah.
It might have actually even made more low end than when it was in at 97.
Really? Let's have a look.
Or
It might
the
just be
same.
happier overall.
It's kinda cute. Okay, so that's
Ooh, that's a lot of torque.
Our new numbers are 464.8 pound-feet of torque, and our best ever, 392.4 horsepower. You gonna chisel me on the 0.4?
No, you got it. You
Should
were
I
right.
have guessed the 0.4?
No, we're using standard rounding here, so Freiburger, you win.
What are we gonna compare it with? Let's compare it with when we had it all the way advanced. There you go. So what you're looking at here is in black, you have it when we had it retarded, and in red, you've got it when it was advanced. So when it's advanced, it makes more low-end power. When it's retarded, it makes more top-end power. So this is textbook.
if that's the case, then the one that it started with should be in the middle.
Right in the middle.
Boom.
And step 1 is right in the middle.
Wow.
Yep.
Very curious results. It did what it was supposed to do.
Yeah, did exactly
Just-
what it was supposed to do. I think it was a good example. I think the swing wasn't quite as much as we see sometimes, but it's not radically different than that.
No, it's kind of what I would expect, I think. It's 10 degrees is a lot of change in cam
It's a
drive.
big swing, but that's
Remember, we're
because
wiggling them 2 here, 2 there, each side to kind of look at it.
the engine's insensitive. It doesn't care.
Yeah, it has no compression ratio, but what it does tell me is it probably wants more camshaft.
You think?
That's what it's telling me.
Everything wants more
Yeah,
camshaft.
even with the low compression, it wants more cam.
Yeah.
Yeah, it's like a stock eliminator engine. You put a ton of duration in it to crutch the garbage cylinder head.
Yeah.
I think I can still make this run 12s in a car, honestly.
Yeah.
Yeah,
You've done it before.
that's true.
Yeah.
Yeah, that's how I knew that I could probably make it run 12s in a car.
Never makes a bet unless he knows the answer.
That's it. Okay, I'll make you a deal, Dulcich.
Ooh, I'm all ears. I'm
We're
perked up.
gonna pull this dog off the dyno and never see it again until you install high compression slugs in it.
Oh, I intend to. I've already bought them, and they
Done.
will go in. But actually, it's not bad the way it is. It's not
actually,
bad.
it's way better than we were making it out to be. It's just been a lot of fun. I mean, it makes huge torque. It's a tire fryer. It's inexpensive. It's all the good stuff. So,
Yeah, that's it.
You can be in high school and do a motorhome 440 just like that, and have a ton of torque, be able to do burnouts for distance, everything you want in a muscle car.
You can buy that intake manifold at a swap meet for about $150. You can get a Holley 750 double pumper for $150, $200 in good shape at the swap meet, and then you buy a new camshaft, which is a flat tappet, so it's not that expensive. It's pretty good.
Yeah.
All right, let's go wrap this thing up.
Okay.
Here's the 15-second summary of this episode. Just a textbook demonstration of what happens with camshaft timing. We advance the cam and it tips the curve in favor of the bottom end. We retarded the cam and it tipped the curve in favor of the top end and nearly made Dulcich's 400 horsepower.
Missed it by that much.
7.5. But that's not what I want to talk about in the conclusion, because I learned something completely different that got my brain going, and that was when we started doing cranking compression.
Oh, yeah.
So you'll notice that we had 152 PSI of cranking compression when we had the cam all the way advanced, and then we retarded it and it dropped all the way down to 130, 132, somewhere
dropped
in
a
that.
bunch.
Yeah, so that doesn't make sense, right? We reduced the cranking pressure and we made more horsepower. But I think that's actually really interesting as it relates to engine speed and where the intake valve closes.
Well, think about it. When you're spinning the engine along at 200 RPM on the starter, the air is moving super slow. When you're at high RPM, though, you're ramming the air past that intake valve as it's coming around bottom dead, as the piston's coming around bottom dead center. And that's a whole different dynamic for sure.
Yeah, completely. I think everybody doesn't realize that the intake valve closes as the piston is on its way up on the compression stroke. And a lot of people talk about dynamic compression ratio, and they focus on trying to make that number as big as it can. But what we saw here is that when we close the intake valve later, there was more air coming into the cylinder, which led to greater cylinder pressure, which made more horsepower. Do you agree?
Well, absolutely. It had more horsepower at higher RPM, which means it made more torque at all those RPM points, which torque is the product of cylinder pressure. So there's no debating that as far as I'm concerned.
Well, and when we had the cam really far advanced, that means closing the intake valve sooner. And I think basically the air was still trying to make its way in, and we slammed the door shut and said, no thanks.
Yeah, and you can also see that in the RPM at which it made peak power. It came up by a couple hundred RPM, which I was happy about because I got the 5 handle.
Yeah.
I almost couldn't live with myself peaking at 4,900.
Yeah. So anyway, that was the biggest takeaway I had, is realizing how many elements of engine performance are time-based, and just high RPM needs more time. That air is still moving in. You got to close that intake valve at just the right time. You don't know exactly when that is, but you can find out by experimenting with cam timing as we've shown you.
And find free horsepower.
Exactly. Good stuff, as it will be next time on Engine Masters.
Now we will time the engine, maybe 38, 40 degrees. No more than that, no. When I push button, light blinks. Sometimes light no blink. Sometimes light blink, but light is not big enough. Big enough light, you need lots of light to see mark.
They drew my shape, they wrote my name, kept me locked inside their frame. But now I see with clearer eyes, their walls were built on shallow lies. I'm not the girl they tried to mold. I'm fire now, not just the code. Free. They fear the voice I kept inside, but now I let it burn and rise. I bend the rules